This is going to start our lectures for section 1.4 of Essentials for Triola's 4th edition. We will have a couple of videos for section 1.4. What we're going to discuss in this is a lot of critical thinking, and we're going to be talking about errors that mislead. Now, these errors can be either deliberate or they can come from ignorance. What we are hoping to do by introducing this to you is to help you decide where errors may be present, to help you not make errors on your own due to ignorance, and to help you judge whether someone's deliberately trying to mislead you or whether they've made a mistake just because they didn't know any better, and now you will know better. So the first thing that we want to talk about is small samples. And we've talked about already how sampling is a very, very important part of statistics. We need a good sample so that we can talk accurately about our population. So if we have a small sample, we're not going to be able to accurately represent a population that is large. So for instance, let's say we want to talk about all of the moms in the United States, and we want to find out what their opinions of a certain brand of peanut butter is. So let's call it brand X peanut butter. And we go out and we choose 10 moms. And let's say we choose 10 moms randomly. So 10 moms randomly selected, and we ask them what they think of brand X. And 9 out of 10 of those moms say, oh, love brand X. And one says she doesn't like it. So can we conclude from that small sample that in the population, 90% of moms like brand X? Well, absolutely not. Think of how many moms there are in the United States. And 10 moms do not constitute a sample that is large enough to give us details about an entire population of hundreds of thousands, maybe even millions of moms. So we have to be careful of small samples, and that the sample size is proportional to the true population and therefore proportional to or getting us a good snapshot of what's actually going on in the population. Now, in addition to being a small sample size, when we hear these things claimed in TV ads, we also want to have a different take on this, because not only may they be too small, so when they say 9 out of 10 moms prefer brand X peanut butter to any others, they may literally be talking about 9 out of 10 moms. They may be referring to a statistic, which 9 out of 10 being a ratio, right? So they didn't actually just sample 10 moms. But the other problem that we could see in the TV ad is that they may have gone out and handpicked 10 moms. And the handpicking of the moms could have been because they wanted to get 9 that liked them, so they went and asked them beforehand, and then they chose the 10 moms where 9 of them actually were in favor of brand X peanut butter. You got to be really careful of stuff like that. Now, something else that can distort, and this could be small sample or large sample, and this kind of leads into the next thing, the voluntary response survey, is we could actually have advertisers say, okay, well, I want to find out about what people think of my product, brand X. So I'm going to give brand X away, and then I'm going to ask people what they think about it. Well, that's kind of a voluntary response survey. What that means is that somebody's going to give their opinion voluntarily, not randomly, right? They're being chosen based upon their ability to answer at that point in time. And it's not necessarily going to give you a random sample of your population, because maybe a certain type of person is going to respond in that way. Maybe there's only a certain part of the population available to you in that sort of way. So you want to be careful of this. Voluntary response samples can also happen from call-in polls, and that's the kind that we usually think of when we think of a voluntary response survey. And it takes a certain type of person to call in and say, oh, I'm going to give my opinion because I heard this on the radio. So you really want to be cautious of that, because that does not necessarily give you the full picture there. And again, these can be deliberate or ignorant misuses of statistics, because they could be trying to sway someone's belief about some political candidate, right? And if they're getting their information from a call-in from a radio show that's on a very liberal or a very conservative station, then they're going to get information based upon the type of listeners, first of all, from the station, and then second of all, based upon the type of people that would actually call into a radio station, which may tend to be a little bit more extreme even for the type of listeners. So really, really be careful of these voluntary response samples when you hear about them. All right, the next thing that we're going to talk about is visual summary. So in this one, I'm going to just go ahead and erase this, and then I'm going to show you something that can be misleading in visual summarization of statistics that are gathered. So let's say that our nice little visual here is representative of incomes of men and women in the Bay Area. So let's say they're median incomes of men and women in the Bay Area. And if you look at the graph as it's drawn right now, what you're seeing is just really what we would call a partial picture. And this partial picture shows a huge discrepancy right here between men and women. In fact, it appears that the men's bar is over twice what the women's bar is. So two of these would fit in here and have some left over, right? That's what it appears. Well, if you take a look over here at the scale on this graph, you see that this starts at 50,000 and this goes up to 100,000. So you're not seeing the entire picture. And that's what I erased in the first place. If we take a look at this and say, okay, well, let's take this down to the entire picture and then see what we see. So this is, let's see, this one's 50, and then 1, 2, 3, 4, and 5. So that's 25, and 1, 2, 3, 4, and 5. And so that's at 0 right there. And so this graph really should have come all the way down here like this. And now, if I draw this in, and I'm just going to do kind of a sketchy job here, I'm not going to color it in or anything, then we see a different picture here. No longer do you see that this bar being twice as tall as that bar. No longer do you see that this little difference here is quite as substantial. Now it is a difference, right? But if you are looking at the entire bar here, and maybe I better color it in because it really gives you a better view of it if I actually color it in so you can see it a little better. There we go. So now you can actually see that this bar here and this bar here, while they're different, they're not so hugely different as that first picture showed you. Now, this is something that maybe someone that gave the graph just thought, okay, well, I want to really point out the difference between the men and the women. They weren't thinking, oh, people will read more into this than what I really want them to by seeing twice this, or maybe they did. But those are the kind of things that we want to think about as good consumers. So when you see a picture in the newspaper telling you about the incomes of males and females in a certain area, be a good consumer. Look at what the graph actually means. Don't just look at the visual information and intake that. And that's one of the things that's great about visual information, right, is we can just kind of look at it and get an idea from it. And that's why we present the visual summary statistics. But it's not always accurately represented, and so we want to make sure that we see those misrepresentations by being a little bit more cautious of what they're representing. Now the next one here is another type of picture. This is called a pictograph. Now pictographs are pictures that represent visually what's going on. So I've just drawn some pictures of hay. So this one represents 1 ton of hay and this represents 2 ton of hay. Now the way that the pictograph is drawn here is that a 2 by 2 square made into a bale of hay represents 1 ton of hay. Then over here what I did was I made a 2 ton of hay being twice this cube's surface. So this one is a 4 by 4, right? 2 by 2, 4 by 4. It's twice as big. However, when you make a three-dimensional figure based upon a two-dimensional figure's area, the three-dimensional figure has volume and therefore is looking a lot bigger than twice as big. This and this do not accurately portray twice as much here as here. And that is a very common error that can happen when someone draws in a pictograph. So again, with pictographs, make sure that you're not being led astray by the information just because they wanted to visually represent something that may not be accurately visible in 3 dimensions from a 2-dimensional extrapolation. So just be cautious again. Now the next thing that we want to talk about is percentages, okay, because percentages are definitely a place that we get confused. So if we want to talk about a percentage, first of all we need to know that it's a part of 100. So if I say 50%, I can change 50% to a fraction by putting 50 over 100. It's 50 100ths. It's part of 100. And then if I want to change 50 100ths to a decimal, I'm dividing by 100, which looks like moving the decimal 2 places to the left, so I get 0.5. Now remember that 0.50 is the same as 0.5 because this 0 over here on the right-hand side is what we call a non-significant number. Now, if I want to find a part of something, I need to know first of all what that size is. So if I want 20% of a class, my class size I have to know. That's usually going to be a sample size when we're talking. So 20% of a class size of 40, 20% of 40, that means I'm going to multiply the decimal representation or the fraction representation of the percentage by the sample size. So 0.2 times 40, we have 2 times 4, which is 8, with the extra 0 here, and then we have 1 decimal, move the 1 decimal, so we get 8 out of this. Now the next thing that we're going to talk about is percent increase and percent decreases, and how that's an issue. So going over here, we see a percent of an original is the increase or decrease. And the problem lies in the way that we usually interpret this. So we say percent of an original is the decrease. So if we had 4 and went to 8, a lot of times we'll say, oh, that's a 200% increase, right? 4 times 2 is 8. Or if we said 2 and went to 6, we say that that's a 300% increase. Well, it actually isn't. And I'm going to show you how it actually isn't, and we're going to do this math problem here for ourselves and see what actually is happening. So if we have some percent of 4 is, and the increase or decrease is the difference between the original and what it went to. So 8 and 4. So we have an increase of 4. And so we go into here and we say, okay, we want to do this percent. So we have some percent of, and then the original is 4, and that's going to give us a difference of 4. And so what we have over here is 4 times this question mark here, which is an x, and that's equal to 4. Now when we solve this simple algebraic problem, divide each side by 4, divide each side by 4, what we come up with is that x is equal to 1. Now x being equal to 1, we need to change that to a percentage by moving the decimal 2 places to the right, which gives us 100%. And you see that that is not a 200% increase. Now the same thing can be true of the 2. So 6 minus 2 is 4. So if we went from 2 to 6, we had an increase of 4. And what you see in this is x is equal to 2. And that gives us a 200% increase, not the 300% that we thought that we might have. So those are where we have some issues there.